Hello students, today we will do mensuration problem solving in this video. So let's get started. So before we actually do the problems, the same rule applies. First you will try the problems and then please see the solution. Okay, so let's get started. Just one second, I will just change this color. Okay. So hope you have paused the video and tried the solution. Okay, now let's see the solution. A cylindrical tube open at both ends is made of metals. Okay, the internal diameter of the tube is 11.2 centimeter and its length is 21 centimeter. All right, the metal thickness is zero point 0.4 centimeter. Calculate the volume of the metal. So basically you are given a cylinder. Let's say this is a cylinder that you have. Okay, and you have a internal diameter also. So basically this will be the internal part. Okay, so here it said, so I just drew the cylinder which is talked about here in the question. Okay, so here it said the internal diameter of the tube is 11.2 centimeter. So this is 11.2 centimeter. Okay, the metal thickness, like this thickness, it is said zero point 0.4 centimeter. Okay, so and this both the sides. Okay, the thickness is zero point 0.4 centimeter. So calculate the volume of the metal. So now we need to find out this volume basically. All this volume we need to find out. Okay, so what will be the volume of the metal? First let's consider this outside cylindrical surface. Okay, this outside one. So what is the total diameter of this outside cylinder? It is 11.2 plus zero point 0.4 and zero point 0.4 on this side also. Okay, so plus zero point 0.4. So this will give us 11.612, right? 12 centimeter. So basically 12 centimeter is the outside diameter and 11.2 centimeter is the inside diameter, right? So what is the volume of the metal? So first we will do the volume of the outside cylinder minus volume of the inside cylinder. Okay, that will give us the volume of the metal, right? This is the outside cylinder. We will do first the volume of the outside cylinder. So we will get, let's say first we will get the entire volume. First we will get the entire volume of the outside cylinder, and let's say the internal cylinder was like this. So let me draw the internal cylinder, and we will find this cylinder, and then when we subtract this we get this part which is shaded here. Okay, so which is the volume of the metal. So volume of the metal is volume of the outside cylinder, which is pi r square h. What is r? The diameter is 12 centimeter for the outside cylinder, so radius will be divided by 2. Pi r square times h is, what is the height given? Height is given the and it's basically said as length here. Okay, the length, the diameter of the tube is given and the length of the tube is given. This is this length basically, that is kind of height. 21 centimeter, right? So volume of the metal is pi 12 by 2 whole square times 21 minus this small cylinder now, internal cylinder basically. Pi 11.2 was the diameter, so radius will be divided by 2 square times height and or length is same, right? 21, right? So from here what you get is as pi 21 is as common, right? Pi and 21 is on both sides. So this is 6 square minus 11.2 divided by 2 square. So you can just write 2 5 and 1 2, it's like 2 6, 5.6 squares, right? And pi 21 is on the outside. So once you calculate it, you will get this as 306.24 centimeter cube. So once you calculate this, now it is given, find the calculate the volume of the metal. So this will be your answer. Okay. So basically you have to do just 36 minus 556 times 56. Once you do, you will get a result, and you can use this pi as 22 by 7, right? So 7 and this 3 will get cancelled, so this will be basically 66 times this 36 minus whatever value, this you will get this value, right? So you can just put this value and do the multiplication, you will get it as 306.24. Hope it's clear. Now let's move to the next problem. So this problem, it's given, a given figure shows a metal pipe of 77 centimeter long. Okay, let me use a different color. Okay. So basically it said this one is 77 meter long, 77 centimeter long. The inner diameter of the cross section is 4 centimeter and the outer one is, so this is like not shown properly. Let's say this is the inner one, and let's say there is an outer the cylinder also. Outer, so there is the inner diameter and there is an outer diameter. Okay. So let's say there is an outer surface like this for the cylinder. So now it said the inner diameter of the cross section is the inner diameter, which is a internal one, that is 4 centimeter, right? And the outer one is 4.4 centimeter. Okay. Find its inner curved area, which is the inner curved area we need to find. First we have to find this inner curved area, like this internal for the inner curved area. So number one will be inner curved area. So what will be the inner curved area? You see, in the radius of the radius of the inner cross section is 2 centimeter, right? It's given the diameter is 4 centimeters, so the radius will be 2 centimeter, right? So we know it is 2 pi r times h is curved surface area, and for the inner curved surface area the radius will be 2 centimeter, right? So 2 pi, diameter is 4 by 2, that is 2, times height is 77. So this will give us 22 by 7 times 4 times 77. This will give us 11. So this is 44 times 22 basically. So this will give us 968 centimeters square. So this is inner curved surface area. Similarly, if somebody, the next question is curved surface area. For the outer curved surface area, you see the diameter is 4.4 centimeter, right? So for outer curved surface area, it will be 2 pi. R is the outer curved surface area. So it's like diameter is 4.4 divided by 2, and height is similarly 7.7. So this will give us 2.2. So basically again we will get 22 by 7 times 2.2 times 77, right? So this will give us 11. And let's move to the next page. So what we are 2 times 22, 2 times 22 times 2.2 times 11. Okay. So this we can write as 2 times 22 square divided by 10, right? 2.2 we can write divided by 10, right? So 22 times 22, 22 square times 11. So this is 22 times 484, right? Divided by 10. So if we do the calculation, which I just did right now, you will get this as 1064.8 centimeters square. So this will be your outer curved surface area. Okay. Now let's say you have to find the last one, which is total curved surface area, right? What is the total curved surface area? So total curved surface area is inner curved surface area plus outer curved surface area, this one outer curved surface area, plus what is the total surface area, what is the surface area of this ring, this one. You have to find the surface area of this ring. So let's first find out the surface area of the ring, right? Basically the thickness, surface area of this thickness, right? So basically this is a ring kind of. Okay, so surface area of the ring, let me use white, that is better I think. Okay, so this will be pi capital R square minus pi small r square. So what is capital R? Diameter is given as 4.4 divided by 2 minus pi small r square. It's like 4 divided by 2, right? So this will give us pi 2.2 square minus pi 2 square, right? So this will be pi is common, 22 square is again 484, so 4.84 minus 4, which will give us pi times 0.84. This, if we calculate this, you will get it at 2.64 centimeters square. Okay, so this is the surface area of the ring. So now how many rings are there? There is one is on the top side and one is on the bottom side, right? So there are two rings. So total surface area will be this outer curved surface area, inner curved surface area, and the two rings. Okay. And one more thing, in your boards, don't just write a centimeter square at the end just like that. Either write centimeter square all through, this centimeter square, this centimeter square, this centimeter square, and this centimeter square, or don't write centimeter square at the end, just write 968 and then write answer. Therefore the inner curved area is 968 centimeters square. But I prefer if you guys write centimeter square like this, the units all through. It's just because it applies in boards only, because they see all these things. Okay, so this is very important. Just don't write centimeter square at the end. Similarly, in the previous problem also I did, you see, I just wrote centimeter square at the end, but don't do it. For sure, write a centimeter square at the end like this. Just put it in a bracket and write a centimeter square. Your teacher will be very happy if you do this. He will think you understand it pretty well. So always write the unit all through the equal sign. Okay, please do that. So what will be the total surface area? So let me just do it here also. Centimeter square, centimeter square, centimeter square, centimeter square, and centimeter square. Okay, so total surface area will be curved surface area for inner cylinder plus curved surface area for outer cylinder plus surface area of the ring plus 2 times surface area of the ring, because two rings are there on the top and on the bottom. So what is the curved surface area of the inner diameter? This came as 968. So 968 plus what was the outer one? The outer one came as 1064.8, and then this one came as surface area of the ring came as 2.64. So once you do this calculation, you will get it as 2038.08 centimeter square. Please check the answer. So you will get this. Okay, hope this is clear to you guys. Also again write like this, centimeter square. So this is the answer to question 2. So let's move to your next problem. So same approach, please try it on your own first and then we will do it. Okay, so let me try this red. I think this is better. It's good to the eye. Solution: a cylindrical roller made of iron is 2 meter long. Its inner diameter is 35 centimeter and the thickness is 7 centimeter all round. Find the weight of the roller in kg if 1 centimeter cube of iron weighs 8 gram, right? So basically it's like this thing is given 1 centimeter cube of iron weighs 8 gram, then how much is the volume you need to find of the cylindrical roller, and that times 8 gram you will get the weight of the roller in kg, right? Because 1 centimeter cube, if it weighs 8 grams, so let's say you have x centimeter cube, then how much will it weigh? 8 times x, that much of gram it will weight. So you have to divide by 1000 to get it in kg, right? Just unit conversion. So first we have to find the volume first. That's our first task. Let's say cylindrical roller made of iron is 2 meter long. Do you have another sheet too? Okay, it's here only. Okay. So this is 2 meter. Its inner diameter is, so there is a inner diameter. So inner diameter is 35 centimeter. Okay. And the thickness is 7 centimeter. Both sides thickness. All round. Find the weight of the roller. So what is the outer diameter? Right? 35 plus 7, right? This side is 7, this side is 7. Middle diameter is, inner diameter is 35. So the outer diameter will be 35 plus 7, right? So it's like for 14, 49, right? 49 centimeter. So basically we'll first write outer diameter equals 35 centimeter plus 7 centimeter plus 7 centimeter. So you get this value as 49 centimeter. That's your first thing. Now you have to find out what is the volume. What is this part, what is the volume? So they have given you the thickness. The middle part it's hollow, right? This part it is all hollow. Nothing is there. This is hollow part, right? So you have to find what is the volume first. So basically this part you have to find out right now. Okay. So let me do it in this color. It will maybe little bit is fine. So the volume is pi times pi r square times h, right? This r is 49 divided by 2 times h. H is 2 meter, it's given. We will convert it into centimeters. So 200 minus pi, this is 35 divided by 2 square times 200. Right? Hope this is clear to you guys. Now we can do is like pi and 200 we can take it as common. Even 2 square, this 2 square we can take it out as 4. So we are left with 49 square minus 35 square. So you can see this gets cancelled. It's easy, 50 pi. But 49 you can write it as 50 minus 1 also, right? Square. And 35 square is easy. So you know, I guess 35 times 35, how to find it? 5 times 5 we will first write 25, and then the first letter first digits will be, if it's 3 times 3 you will do 3 times 4, so it's 12, 12 25. Let's say they have given you 65 times 65, so the end two digits write as 25, and the first digits will be, you have to do 6 times 7, 7 6 are 42, so the answer is 4225. So this is just a easy way to do squares which ends with 5. Okay, so 35 square is 12 to 5. So here you get it as 50 pi. 50 square is this plus 1 minus 100 minus 1225, right? So you can just keep it like this, 50 pi times what is 12 this thing. This will come out as 1176. Okay, so 1176. So write centimeter cube all through. I'm just writing here centimeter cube. So you will get the volume as this centimeter cube. Okay, so please write centimeter all cube. Otherwise, in exam they might deduct 1 marks from you. Okay, so I'm just saying this from experience. So find the weight of the roller in kgs. Therefore, what is therefore required weight of the roller? What is the required weight of the roller? This will be, it weighs 8 gram for 1 centimeter cube. Then how much will it weigh for this thing? 50 pi, this is 22 by 7 times 1176. This much centimeter, this much is the gram, right? This much gram is there. Now if you convert it in kgs, it should be divided by 1000. So it should be in kgs. Okay. So if you do this 50 times, this will be 20, right? If you do it one more, 10, it will be 4. Uh, does this get divided? Yeah, so this gets divided also. So, so 7 and 1176, it will be 168. So basically you are left with 168, 22, 4 and 10, right? So basically 168 times 22 times 4 is 88, right? 160 times 88 you have to do, and then divide by 10. So you will get the answer as, just writing the answer here, you will get the answer as 1478.4 kgs. This will be your final answer. Find the weight of the roller in kgs. So you can just find the weight of the roller like this. Okay, so basically find the volume, and 1 centimeter cube of the volume weighs 8 grams. So x centimeter cube volume will get multiplied with x, and when you divide by 1000, it will give it in kgs. Okay. So having said that, let's move to the next problem. Please try it on your own, and then we can find the solution together. So what they asked you here is, they have given you a semicircle. Okay, sorry, the center semicircle of 35 centimeter. Now when you fold this semicircle, it will actually gets converted into a cone. Okay, this semicircle will get converted into a cone. With this 35 centimeter will become its slant height, which is this will become 35 centimeter. And this part basically, I'm saying this part is is this part. The perimeter of this semicircle basically will be the basically this part of the cone, this part of the cone. Okay, basically the circumference of the base, let's just say it. Okay, so now I will show you a video just to make it clear to you guys, like how this semicircle is getting converted into a cone. I found a very good video in the YouTube. I would just want to share this with you. Okay, please see the video. Can you see how the semicircle arc or semicircle arc is converted into the circumference of the cone, and how the radius of the semicircle is converted into a slant height? Okay, just see one thing here, how this part which is the arc of the semicircle, how this is getting converted into the circumference of the cone. See this, you see now this is the circumference of the cone. Okay, and again this is one more important thing, I'll showing you again one more time. This is the radius. Now the radius will be the slant height of the cone. See, this is a slant height now. That was the radius before. Okay, so this is a pretty good video. I was not I saw this video and thought, okay, let me share this video with you guys. So okay, so I think you guys got it. Yeah, so let's move to the problem now. So I hope this is clear. This radius will be the slant height, and we understood what will be the base, the circumference of this cone. So now they have asked us what is the radius of the cone. Okay, the radius of the cone, let's assume it as r, and the lateral surface area of the cone also they've asked us from us. Okay, so since this part, this circumference of the cone, of the base of the cone, is equal to this arc. What is this arc? So this will be 2 pi r divided by 2, right? Because it's a semicircle, right? So basically pi r, right? So this part is pi r, right? If it's a, sorry, if it's a complete circle, then what's the circumference? 2 pi r, right? But if it's a semicircle, it's pi r, right? So pi r will be equal to this. What is the circumference of this base? That is pi r square. Sorry, 2 pi r. So 2 pi, because it's a complete circle, and we have assumed this as r, so we kept it as 2 pi r. Now r is 35 divided by 2, which is 17.5 centimeter. Okay, this is answer 1. Now you do 2 here. What is the lateral surface area of the cone? Okay, so what is the lateral surface area? So which is, what is the lateral surface area of the cone? First, let's write that. Lateral surface area of the cone. So lateral surface area is same as that we call as curved surface area, right? So this will be pi r l. So pi r, now we know what is the r of the cone, and l we already found out what should be the slant height of the cone. This radius of the semicircle should be the slant height of the cone, right? So r is 17.5, l is 35. So we know pi is 22 by 7 times 17.5 times 35. This gives us 5. From here you can just do 17.5. 5 you can write as 10 by 2. This will give us 11, and 11 times 175. This will give you 1925 centimeter cube. This is a centimeter square area, right? Always all write centimeter square all through. I'm just not writing it always, but please do so in your exam, and please do so while you practice also. Okay. So I hope you understood how we are finding the radius and the lateral surface area of the cone in this problem. Okay, let's move on. Let's go to the next problem. Similar thing, please try it first. All right. Okay. So what is the solution? A water for a factory stored in a hemispherical tank. Okay, there is a hemispherical tank. Okay, of diameter, internal diameter. So let's say this is the internal diameter. Okay, of 14 centimeter. There will be another external. Let's say there is some thickness, and it can be like this, but it looks like we don't need to draw it in this problem. Okay, because it says about water, how much it stores water. So if how much water is stored, only the internal diameter is required, right? So the tank contains 50 kiloliters of water. So the tank contains some sort of water. Water is pumped into the tank to fill to its capacity. Okay, let's say the tank contains water up till here. So this is 50 kiloliter of water, and water is pumped into the tank. So they are adding water basically to fill to its capacity. Now they will fill this part also. Everything will be filled up. Find the volume of the water pumped into the tank. So how much volume are being put into the tank, into this hemispherical tank? So basically this part which I'm marking right now, this part is basically total volume of the hemispherical tank minus 50 kiloliters, right? That will be the amount of volume of water that needs to be pumped into this tank, right? So basically we can just do required volume of water, volume of water pumped into the tank can be written as volume of the hemispherical tank minus whatever volume was left, right? Minus, it's saying the tank contains, so 50 kiloliters of water, volume of water left in the tank basically. So what is the volume of hemispherical tank? This is, we know, right? 2/3 times pi r cube. R is 14 divided by 2 cube. This is the volume of the hemispherical tank minus volume of water left is 50 kiloliters. Okay. So I'm just writing 50 here. This 14 is in meter, 2/3 pi r cube. So we will get meter cube. So meter cube and kiloliter are same basically. Okay. So 1 meter cube is actually 1,000 liters and 1 kiloliter is also 1,000 liters. So both are same. So I can just keep it like this and just write kiloliters here. So now it will be 7. So 2/3 times 22 by 7 times 7 cube minus 50. So we get this much kiloliters. So this will get cancelled and we will get 7 square. From here it's 44 times 49 divided by 3 minus 50. So from here if we calculate, I already did the calculation before, it will be 668.67 kiloliters. Okay, so find the volume of water pumped into the tank. This will be the answer. As simple as that. Hope you guys have understood the problem. In case you have any doubt or confusion, please let me know in the comment section, or yeah, just let me know where is your doubt. I will explain it again. Okay, it's not a problem. Okay, so let's move to the next problem. Okay, we have some space here. The adjoining figure shows a model of a solid consisting of a cylindrical surmounted by a hemisphere at one end. Okay, if the model is drawn to a scale 1 is 200, find the total surface area of the solid in pi meter square. Number 2, the volume of the solid in pi liters. So they asked us two things. One is the total surface area of the solid and the volume of the solid. Okay, let me change the color of the pen. Okay, so let's do the first problem here. Total surface area. What will the total surface area of the solid? You see, this part is a cylindrical, this part is a cylinder, right? This is cylinder, and this part is a hemisphere. So once you do the total surface area of the solid, you can find the surface area of the hemisphere first. Okay, then the surface area, basically the curved surface area. Okay, where among the cylinder and the hemisphere, and then since they have asked to find the total surface area, add this lid, basically this circular lid, add this circular base to the curved surface area of the cylinder and the hemisphere. Okay, curved surface area of the hemisphere. All right, so what is curved surface area of the cylinder plus curved surface area of the hemisphere plus area of the base? This you need to find. Okay, this is not showing well. White is better. Okay, so what is a curved surface area of the cylinder? This is pi r square times h, right? So r is, h is 8, r is 3. So pi 3 square times h will give you the curved surface area of the cylinder. But now it's saying it is, this is a model. This is a model. But they asked us to find out the total surface area of the actual solid. So if this model is of the model to solid ratio is given as 1 is to 200, right? Model to solid ratio is given as 1 is to 200. That means if model is 1 centimeter, solid will be 200 centimeter. If model is 1 centimeter square, that is 1 centimeter times 1 centimeter, then solid will be, corresponding solid will be 1 centimeter is 200 centimeter, right? And this again 1 centimeter is 200 centimeter. So then the scale will be this 200 centimeter times 200 centimeter. If model is 1 centimeter cube, then solid will be 200 centimeter times 200 centimeter times 200 centimeter, right? If it is 1 centimeter times 1 centimeter times 1 centimeter, if this is the model, then this will be the solid. So similarly, you see CSA cylinder, we have found this for the model, which is pi 8 is the height and 3 is the radius. So this is the model, all are in centimeter cube. So now the solid will be 200 cube. Okay, hope this is clear to you. So, oh, sorry. What I am doing is I just wrote the for the volume formula. Very sorry for that. Pi r square h. So this will be 2 pi r times h, right? So 2 pi r times h. So this is the CSA for the cylinder, right? 2 pi r times h. But if it is for the cylinder centimeter square, so this solid will be 200 square, right? Instead of cube, it should be square. Not sure what's happening. Let me check. Okay. So CSA for the hemispherical area is 2 pi r square, 2 pi r square, right? And since it's square, so since it's r square, so centimeter square, you will do it as 200 square for the solid, right? 2 pi times 3 square is for the model. So when you multiply 200 square, that gives us the hemispherical area CSA for the solid, actual solid, since scale is 1 time 1 is to 200, right? I hope I explained it pretty well here. Okay. And then what is the area of the base? Area of the base is pi r square, simple, pi 3 square. Similarly, you have to do 200 square. Okay. So after that, it's just calculation. So once you do this calculation, you will get this as 300 pi. And since, okay, so you have to just convert it into meter because you will get it as centimeter cube. When divided by 100 times 100 times 100, you will get it as, so sorry, you will get a centimeter square, right? Because it's total surface area. So when you divide by 100 times 100, you will get it as meter square. Okay. So this answer you will get it as 300 pi meter square. They have asked you what is the total surface area in pi meter square. Okay. It's a easy calculation. You can just do 8 times 3 times 2. Okay. 24 times 2 is 48 times 200 square. Just 200 square, keep it outside for all the three bits common, and pi is common. So you can do basically uh, 48 plus this thing 9 times 2, which is 18 plus 9. Okay. Like that you can perform your calculation and you will get it as 300 pi m square. And the other one is, what is the volume of the solid in pi liters? What is the volume of the solid? So volume of the solid is basically volume of the cylinder plus volume of the hemisphere, right? So total volume of the solid will be volume of the cylinder plus volume of the hemisphere. So volume of the cylinder is pi r square times h, right? What is r? R is 3 square. Pi r square times what is h? H is 8 centimeter. And is it said 1 is to 200, right? So it's like centimeter cube. So we have to do 200 cube. This will be the volume of the cylinder. And what is the volume of the hemisphere? What is the volume of the sphere? It's 4 by 3 pi r cube, right? So volume of the hemisphere will be 2/3 pi r. R is again 3. 2/3 pi r cube, right? And then you have 200, 1 is to 200 in scaling. So this is the volume of the model. So what is the volume of the solid? 200 cube. So similarly, now you can just take pi and 200 cube as common, put it out. This will be 9, so 72. 9 times 8 is 72, plus this 3, it will be 3 square. So 9 times 2 is 18, right? So pi 200 cube times 70, 88, 90, right? So this you can write as 100 cube, and this 2 cube will be 8, right? 8 times 90, so it's like 720 times 100 cube times pi, and everything is coming in centimeter cube, but you need to find it in liters. So 1 liter is equals to 1000 centimeter cube. Okay, so basically then it will be 720 times 100 times 100 times 100. You have to divide it by 1000 to get it in, to get the result is in liters. So 1000, this 2 will get cancelled, this will get cancelled, it will be 720, and then 1 2 3, 720,000 pi liters. This will be your final answer. Hope you guys got this problem, you understood this problem. Let's move to the next question. Now it is saying, this came in ICSE by the way, 2007. The surface area of the solid metallic sphere is 616 centimeters square. Okay, it is melted and recast into smaller spheres of diameter 3.5 centimeter. Okay, how many such spheres can be obtained? Okay, the surface area of a solid metallic sphere. So the first surface area, which is a solid metallic sphere, so we have this sphere first. Okay, and now it's said it is melted and recast into smaller spheres of diameter 3.5 centimeter. So here you will get some radius, some diameter. Okay, let's say this is r, and this is melted and recast into smaller spheres of diameter. So this diameter is given as 3.5 centimeter. So how many such spheres can be obtained? You see, basically this bigger sphere is getting converted into many such spheres, many such small spheres, and we need to know how many such small spheres is equal to this big sphere. So this is, let's say, x number of small spheres. So according to the rule, the volume will be equal. This volume of the solid metallic sphere will be equal to all the volumes of the small spheres, and all are equal, right? So basically volume of a smaller sphere, and since all are equal, you have to multiply it with x, right? And you need to find what is the value of x, and you can assume it. Let us consider X number of such spheres can be obtained. X number of spheres can be obtained. Okay, so once you assumed it and once you understood the fundamental, how the crux of the problem, basically how it can be framed, then it is a piece of cakewalk. You have to just solve this equation. The volume of the solid metallic cylinder, solid metallic sphere is what? 4 third pi r cube. What is r? So r you don't know. You need to find what is r cube. Okay. And here x, what is the volume of smaller sphere? 4 third pi. What is r? 3.5 divided by 2. Right. So this one is there. You need to know the value of r. For that, they have given you the surface area of the solid metallic sphere is 606. So what is the surface area of a sphere? 4 pi r square, right? 4 pi r square is given as 616. This is the surface area of a sphere, 4 pi r square. And what is the volume of a solid metallic sphere? It is 4 by 3 pi r cube. Okay. From here you see 4 gets, you get this get divided by 616 gets divided by 4. 4 ones are 4, 21, 20, 154. Okay. And this is 22 by 7. So let's do r square 154 7 times 22. So 11 sevens are 14, 1 sevens are 14. Okay, so this is 7. So we get r square equals 7 times 7. So from here r equals basically plus minus 7, or you can then write, since r cannot be minus 7 since its radius, therefore r equals 7. Right, so you get the radius of the bigger sphere as 7. So just putting r equal to 7 in this equation, you get 4 by 3 pi 7 cube equals x times 4 by 3 pi 3.5 divided by 2 cube. Here 4 by 3 pi gets cancelled, and you have, basically you are left with x equals, so you see 3.5 can also be written as 7 by 2, right? 3.5. So basically you are left with 7 cube, and here since this can be written as 7 by 2, so basically 7 cube times 2 to the power 4. I'm very sorry about this calculation. This will be 7 by 2, so 2 times 2 is 4, so this will be 4 cube, right? So this will get cancelled, x will be 64. Answer is 64 number of such small spheres can be obtained from recasting this, or melting and recasting into smaller spheres. So melting this big solid metallic sphere, you will get, it can be recasted into 64 number of smaller spheres. Okay, so now we came to the last problem. Please again similarly try this problem before you see the solution. Okay, so it's saying a vessel in the form of an inverted cone. Okay, let's draw a vessel first. Its height is 11 centimeter. Fine. And the radius of its top, okay, radius of its top which is open is 2.5 centimeter. It is filled with water up to the rim, like up to the top it is filled with water. Okay, this there is no portion left where it's not filled. Everything is filled with water. When some lead shots, each of which is a spear, all these lead shots, so let's say X number of lead shots, each of which is a sphere of radius, is given sphere of radius. All these lead shots are sphere of radius 0.25 centimeters, are dropped into the vessel. Find the number of 2/5 of the water flows out. So whatever is the volume of the water right now, 2/5 of that flows out. So that means 2/5 of the volume of water will be equal to whatever is coming in, right? Whatever volume of lead shots is coming into the cone, that much amount of water is flowing out of the cone, right? What, how much water is flowing out of the cone? It is saying 2/5 of the water flows out, basically 2/5 of volume of cone. So this much amount of water flows out, and how much volume of water comes in? It's x times volume of a lead shot, basically a spear, right? So these two should be equal. So basically it should be like x times volume of a lead shot. Okay, it gave they gave us the radius also 0.25. So basically 4/3 pi r is 0.25 cube will be equal to 2/5. Volume of the cone will be, what is the volume of the cone? 1/3 volume of cylinder is volume of cone, right? So that is pi r is 2.5 square times height they have given us 11 centimeter. So all they have given is in centimeter. So this will help a bit. Okay. So this 3 and 3 gets cancelled, and then you can simply just do these calculations. Basically 2 and 4 will get cancelled, pi and pi will get cancelled. All right. So what are we left with now? X. Okay. 2.5, you can write it like 25 square, and that will 2.5 by 10 square, so you can write 10 square here. Okay, and you have like all this in denominator, 5 times 11 times 2 times again 0.25 cube you have. You can just write 25 cube, and you can put 100 cube on the top, right? This I just rearrange the terms. Basically it's the same thing, I just rearrange the terms. So from here you get it as 25. So 10 square, how many squares are there? 0, 0. This many number of squares you have here, right? And you have 100 here. So basically cancel these two, and then 25, it will give you 400. Okay, and this is 5 and 2 is 10. This will give you 80. So one thing, just a silly mistake here as I see, this 11 is not here, the 11 is on the top numerator. Okay, so from here this 2 will get cancelled, it's 40. So from here x we get as 440. So I hope you got a flavor of the kind of problems you expect in mensuration. I just selected 8 such problems from different kinds of problems. But I hope this session was helpful to you. I do not want to extend this session beyond this, but if you guys need one more session on mensuration, let me know. I will bring some other problems and we can deal with that. Okay. Okay, that was it for this session. Please like and share our videos if you like. Also, please subscribe to our videos. That will help us to reach more people just like you. We are trying to build a math friendly community. Okay, all free of cost. And thank you so much again. And please let me know if when you have any problems and so far. So stay good. Okay, take care. Bye. Good night.